So yeah, in NP we have NP arrange was there. Let's create little bigger till 16. And what we are going to do is we will reshape it to 4 cross 4. So it is like yeah, you when you print, I think you can observe it. Now it is an array. What it does, it's created this piece created 1 0 to 15 numbers, and we change that shape into 4 cross 4. Okay.
Yeah.
Yeah, in this array, it is yeah two-dimensional now. So how you can access the each array values actually? That is the question. So when you press 0, it is giving you the first row. So
Okay.
when you are giving like this, it will give you first column.
Is this a format?
Yeah,
Like
yeah. These
we
are
actually
like
do.
proper syntax in
Okay.
yeah. When you pass 0, it will give you this. Will have first row a first column when you have to give you can pass like this, and in this you can actually mention here certain columns also, set of rows. So first, second, third row, so 0 to 3, and again you can mention it's like only give me first two columns, so it will give you like this.
Okay.
Okay. Yeah, I understand these are like simple list. In the list also we were doing start and one more was there, skip.
The hoops.
Yeah, so in these also you can do that. Actually, in these one, uh, zero column, sorry, four can also be there because 4 minus 1 will work actually. And suppose you are giving 3. This is saying first 3 rows only, columns I node. Here also actually you can do this minus 1, which will reverse the order. Sorry, not reverse. Actually skip some orders, some columns. So when you pass this 2 is like it is saying I will be taking first column from 0, then I will go for second column. So subsetting is happening something like that. So for time being, suppose we take an array of, let's say, the previous this one should be np dot arrange range, and we did like 100. So what I am trying to say is, so if you want to get some particular five, so first five, oh sorry, in this one first five will come like this. So
Now this is like it's having a 0 to 100th in a. Okay.
yeah, 0 to 100. Easier to visualize actually. When you pass some 10, so it will start from 10 onward.
Like, okay. Okay.
Correct?
Yeah.
When you pass this 2, it will do
Two
select
skipping
the
ones.
second, all second ones.
Right.
And when you pass 3, all third ones.
Skip the position by 3.
Yeah, skipping the position. And I think you cannot pass the minus numbers, but you can do this also minus 1, but your order should be reverse, I think,
Okay. Even in list it happens same way.
in the reverse order
Okay.
till 10th. And in this, yeah, actually, it is not reverse, actually, it is doing saying that first element take that value and yeah, reversing actually. Yeah, second index, then go to the second index like minus fourth one and minus. So this way actually you can easily reverse it and all. And but I was giving this example to how to subset the indexes of entire NumPy array. So I will, yeah, meaning after this class, definitely go and try these.
Okay.
Otherwise, yeah, you will get confused with the how to select them. So suppose I ask you to select only 10. How you will write?
One, two, three.
Yeah,
Three
for
colon
10. Let's try here. Yeah, array
arrays.
and 3 colon 3. It is not. So
Zero,
actually 2 colon 2.
two colon. Two colon.
Yeah, so start with 0, it will give you this. Let me try this works or not. I think this way also it works. So
Okay.
you can either mention 2 comma 2 or square bracket 2 and 2. Okay.
Okay.
And yeah, because in the NumPy exercises you will find such questions. Yeah. And these are like a basic to know this. And we talked about shape and all. I think this you already remember. It's it will
Matrix.
say, yeah, matrix size,
Dim.
dimension, and in arrays, n dimension is also there, and dimension. Oh, n dim. Yeah, correct. This is method. Oh, this is also not method. So it will say two. And you might be knowing this transpose and all. Do you know?
Uh,
We
Concept.
can do columns to rows and rows
Column
to
series and
columns.
rows to columns. Right.
Yeah, correct. So whenever you need transport, you can write dot t. This will do the transpose. So suppose you want to do operation like array transpose, you saved it here into array transpose and array is already there. Then if you remember array transpose into array, it will able to generate something for you. Yeah, it will multiply each of the element. Actually, it is a square then.
Array t into
So array transpose is meaning rows to column and column to rows.
columns.
Here actually we can check here like array transpose is this and array was the same initial one which we defined. So when you did 0 into 0 it will 0, 4 into 1 it is 4,
Oh, okay. Okay. Oh,
8 into
okay.
2
It
it is
is
16
16.
and 3 into 12 36. Last
Okay.
one is 15 into 15. So these are the some things, and the interesting thing here is we call this step as a broadcasting. When you actually want to this, I yeah, multiply with 9. So what it does, it broadcasted this multiplication or multiplying by 9 to all the elements. Now you can see all the elements are multiple of 9.
Nice.
Similar things you can do with the addition. You want to add something, it will add to all of the elements. Either you can subtract also, and similar you can do divide also, and any operation actually. This, if
Sign
you,
of.
yeah, np dot sign, if you take and then pass to this,
Okay.
it will take sign of all the values and store it. This we known as broadcasting. And yeah, actually this piece. Uh, Again, we go back to this array, one dimensional. In this one, also you can do something like this. This is known as actually, yeah, four. So first four elements is this. Suppose you want to store with 100. So you can directly do this and you can see it will change for you. First four elements is 100 now.
Okay.
Okay,
It is like directly you're replacing only some value kind.
correct.
We do it in
Directly you
replace.
can replace giving passing the indexes which values you want to replace, you can replace them.
Okay, will it happen like first to last or last to first or mid somewhere values also we can
This
change?
depends on how you pass this, right?
Okay, okay. If I
So
pass
yeah, if you
five,
want to do somewhere in between, you have to mention, yeah, 55th to 60th I wanted to replace. So replace with minus 10,000 or minus 100. Now if you will check, don't worry, yeah, this is you passing the positions.
okay.
These are not numbers. Actually, position and numbers are matching right now, but it is not matching actually. You can see fifth, yeah, matching actually, but it is not the case. Yeah. So these values are replaced. So what
Okay.
means on at 36th position or 35th position, it is 35th only.
Since it is like 0 to 100, the position
Yeah,
is not.
correct, correct. Otherwise, yeah, we should be doing something else. Instead of this, you can write 10 to, yeah. If this is the case, then things will change.
Yeah, that value of accessing the
Values will change, and yeah, these values will be different then. Yeah, you can see 14 onward.
right.
Yeah, now this when we run, then this we run. This 45th, yeah, for time being, these are the things. Okay, broadcasting and when you want to do slicing and all, this is, yeah, this is also slicing of the indexes. We able to change them. Yeah, in 2D, I just talked first. You can pass this row and column, row, comma, column, two ways
Two
to
separate.
access, yeah, these matrices and some fancy indexing is also there. Shape one, okay, yeah, this is, oh, okay, yeah, many, yeah, it is again in this bigger one, two-dimensional array. Actually, you can pass this also 2 comma 3. So it will directly select. Sorry. You can pass in a square bracket 2 comma 3 double square bracket. Notice. So it is doing what? It is selecting two rows, second row and third row.
Two.
So yeah, let me show you the array. Then you may able to recognize. So when you pass within that square bracket, again a square bracket is there, right?
Right.
So it selected this row and this row. Now suppose your question is like, how can I select columns in this way? So you might be having to pass like this. Oh no, it is not the correct index. Yeah. So some way we can, yeah, for column they don't have. Yeah, we don't have. I think column. Okay. Yeah, these are for rows.
Now this is considering like a two-dimensional array, or this is like just normal array operation itself.
Yeah, these are array actually, and but how we are subsetting and all. So similarly, in this way, you can get the columns also.
Colon.
For the, so notice you are getting 2, 6,
Second
10, and
colon.
14, and 3, 7, and yeah, you can pass one also, anything actually.
Okay.
Okay, and rows, column subsetting. Now, another thing we generally need to check is some things in that array is meaning you want to do comparison or something, so you will check they are directly pass this, you can check the values. Oh, what happened? Okay, control Z is there, yeah, it deleted. So suppose you want to check 5, sorry, 10 greater than 10, who all are greater than 10, you can pass This is actually one is so this value is giving true or false boolean values, right? This
Right.
is known as masking. We call it mostly generally. We mask it. Yeah, we know these values satisfy the condition. Some values not satisfy the condition.
Okay, let me take a minute. It is comparing if the first value is greater than 10. So it's not, so it's printing false. So when the condition is matching, there it is giving a true.
Correct. So this is another kind of mask. Now,
Mask.
what is like you want to check? Uh, yeah, you wanted to check is the values are greater than 10. But now you know, yeah, these values are greater than 10, but I need to print them, or you want to get them, those values who are greater than 10. So you can write, take the square bracket, take the array, keep the masking inside it, and return the values which are correct or satisfy the condition, this condition. And I think again also you can go and is also there. Maybe I'm also let and you can write which are lesser than 5. I think in these cases when you want to do multiple you have to pass in brackets. This will never fall, right? Because I don't think so.
Or we can try.
Because it will not fall because any number cannot be greater than 10 or lesser than 5. So you have to pass like this, lesser than 10 but greater than 5. So these are the numbers in that array. So if you want to check, I think like this, if you remove the masking is like this. So these elements were
True.
satisfying this
Those were
condition, that is like greater than 5 and lesser than 10. Okay, this
yeah.
is we this initial internal, yeah, this entire step is known as, yeah, masking. We did some masking, or you can say put some condition, and we find out the elements which are satisfying those conditions, yeah, on the array itself. So generally, yeah, these things will come into your daily coding practices also, or in the later on when you are coding something. And again, yeah, the masking and all is there. It will be always boolean and all. And actually you can pass this masking to any other thing also. So when I says other thing, actually you can say if the masking and both are dimensionally same, so you can pass this on transpose also, the because they were actually same, right? So somewhere you can say I stored this mask in some variable and you pass here. It's like checking that value, but yeah, it is throwing some error, but don't know. Yeah, but in this way, actually, you will see the values are not. Oh, okay, okay, correct. They will not match the condition actually. So better to pass the same array because it is based on index. Ah, yeah, this. I think these are fine. So far, good. Are you with me?
Can we match like I mean, 2
I think,
cross
yeah, it's
2?
not advisable to try on different data set or different masking because it's help because you created the masking or condition based on the this array, right?
Right.
Better to use on the same array. Yeah.
Can we have
Okay.
two different arrays, like one with a matrix of two row, three column, the
Hmm.
other with like a three row, one column kind?
And what do you want to do?
Three row, one column, or three row, four column. Like,
Correct.
what is this? The dimension is a different way. So, like that
Oh,
also
okay.
you can do here.
Yeah, yeah. So suppose we have array. I just replace the one or here one or two dimensional, and let me say we have arrange 12 so three dimensional 3 cross 4, right? Reshape 3 comma 4. So for you just print this, and so you can see this will be 3 rows,
Four
4
columns.
columns, correct?
Right.
Yeah, in these masking will work, but if you pass some other masking, it will throw error, I think. So suppose you pass this mask, will throw error because some of the indexes not matching, because it was this mask was meant for 14 4 6 4 cross 4, right? 16 elements were there.
No, no. Yeah, my question was not for masking. Like a cross dimension multiplication kind. Like,
Yeah, actually those are possible, but what will happen, you have to match the, because algebra says you cannot multiply non, so there is mat mult is there, matrix multiplication, mat mul, which actually does that operation where you pass two of the matrices and you can multiply them.
okay,
And the condition is the first matrix M1 should be of comment. This is, yeah, basic, you can say algebra class M2. So dimension should be like, for example, n cross m, sorry, m again should be m cross p. Then these two can be multiplied and the resultant will be actually n cross p. That is well known fact.
right.
And when you are doing that multiplying, like similarly simple two matrices, then both dimensions should be same actually. Otherwise it will throw errors, or yeah, it will not make sense actually.
Okay. I asked this because like there might be some. I mean, Python is having many defined libraries, right? So there might be
Yeah,
something to
many
handle there.
functions are there, correct. And let's for time, so if you want, let's create another two dimensional, but I will say it some other variable or something. Yeah. So this is suppose 4 cross 5. Okay. So 4 cross 5, how many elements we need? 20.
20.
Correct. Now if you want to do the multiply of these two, where you can check, I think. So this one has one was having 3 cross 4, again was 4 cross 5. You will get the result 3 cross 5.
Okay.
This we known as matrix
Multiple.
multiplication. Yeah. Now let's talk about some other. Array has many other features also, like if you want to do sum, you can directly call get the sum of the all the elements. Similarly, I think you can call this array and get the mean also. So when you type mean, yeah, is giving you summing all the elements dividing by number of element. If you
Mm.
sum over till 14, sorry 15, because it was 4 cross 4, it will come this. And inside this, actually, you can pass two things. Which axis you want to sum or get the mean. So you can get like this. So
Oh,
what it is giving you is some, sorry, mean over array is there, right? Mean
right.
over this elements, I think. Sorry, this first row, second row, third row, fourth row. Correct or not?
No, no,
Check.
I'm not getting it. Axis of zero in the sense which side it is taking, like a
Sorry,
column
yeah, axis is 0. I think the mean of this 0, 4, 8, and 12.
12,
So
24,
this
12.
is giving you x is equals to 0 meant by column wise mean.
Hmm, I'm still not getting that.
Column wise mean. No, no, just sum. 4, 0 plus 4 plus 6, sorry, 4, 8, and 12. What will be the mean?
24, 10, 12, 20, 24.
Divided by 4. 6.
Oh, okay, okay, okay. It is taking the
Okay, yeah.
column and dividing by 4. Columns
Yeah,
and dividing.
similarly, you can do here also. Sum is also axis wise. When you write x is equals to 0, it is going to give you sum over columns, right?
Okay,
This
now
is
I understood.
24, 28, 32. When you pass the 1, it will give you row wise sum.
Okay. Here, axis in the sense it is referring for a columns.
Hmm.
For rows, what we will refer as or
Same,
x.
same. X is equals to 1. Now it is giving you based on rows, sums. You can sum over this. 6, this is 22, this is 38, this is 54. When you pass this, parameter is only changing 0 and 1. 0 for column wise and yeah, column wise sum, and 1 is for row wise sum. But actually, yeah, little tricky to understand, but I can say is like how to remember this. Yeah.
Yeah, that would be helpful.
Generally, what happen? Yeah, you just play around and yeah, yeah, this is the correct one. Use it. Meaning what you want. That depends, right? Sometimes you want column wise, you will pass 0 as an. If you want one row wise, you will pass 1. So similarly, you can calculate the mean also in the same axis and row column wise. Even standard deviation also comes into same way. You can directly call STD is there. I think yeah, STD and pass axis whatever axis you want. It will give you same x because it will be always same standard deviation. For these numbers, standard deviation will be not changing. Yeah. One more is there. Array. So we are in a one dimensional now, and we are having this cumulative sum and cumulative product. So let's talk cumulative sum. You aware, right? Total sum or running total, we call them.
Uh, no, I'm not.
No, it's summing the first element to the next element and next to next, next to next.
Okay, consecutive addings. Okay.
Yeah, cumulative. Yeah.
So
And similarly
cumulative
for
multiplying
product
by.
also is there. You can multiply also, right?
Okay. So this is
Yeah,
actually
these are like already defined. You don't need to worry and yeah, just do your operation. Somewhere it is 0 because that's why it's yeah, converted everything into 0.
okay.
Somewhere it was negative, so yeah. So no need to I think we when you pass I think two dimensional we should check how it is working. Oh, this is not doing anything.
Unless
It's a
line.
meant for only one dimensional, yeah.
Okay.
No point of trying on yeah two dimensional. So these are the some things we had. Yes. So we just checked that condition, right? saying that there is one this NP where it will check some condition on any of the element. It is saying suppose two. Oh, okay. NP array. Why it is giving two arrays? Oh, sorry. Array was, yeah, actually, yeah, the syntax is little different. Yeah, it is saying whenever you, it's conditional what to say, replacement. So what it says is where it is true, replaced by 2, okay. Where it is false, replaced by minus 5, minus 2.
Okay, there was some zero to this thing. So since zero
Yeah, we
is
can check
greater,
what was the array. So you can check array was this value. So greater than 5. So 6 onward, these rows are 2. Or let's say better to write 20. And which are lesser, they are minus 2.
oh,
So this is one of the, yeah,
what is this called as, Rishi? Like np dot where there is some name or it is just a method kind?
it's a one method in NumPy
Okay,
where you actually, based on the condition, you want to replace the numbers from the array, right?
okay,
Example can be, it is again a kind of masking only. So, but you want to replace them directly, those satisfy, you can say these are, actually, I think you can replace by this string and all. Then you can say these values are high side, others are low side. So, like grouping,
okay,
and later on, you want to do some analysis on plotting something. Bar chart, yeah, let's plot the bar chart and check how many are low, how many are high.
okay.
Something like this can come into in your use cases. That is one of these things. Similarly, you can sort also based on access. Let's try those also. Array dot sort, and when we call this, I think access, no point of sorting. Yeah, sorting will actually help on like one dimensional. Let's, so you can sort based on this. But yeah, suppose you have array of some, what to say, names or some list of strings. So Monday is there or some Tuesday is there, yeah. But that does not make sense. Monday, Tuesday, let's say Mumbai is there, Thane, Pune, Nara, one, and one more we can bring from Goa, suppose. If this is array, city name we can call them. Then in case you want to do sorting on it, so we know, right? We can call this sort. Sorted was already there. So here actually you can also call them np dot sort. and it will do sorting based on alphabetical order, I guess. Yeah.
Okay. What is this? After the
Okay.
answer, we are getting something. D type is equal to some U60 something.
Unique code, yeah. So these numbers are actually represented in some other format. I think Unicode format generally they represent. Yeah.
Okay, this has nothing to worry on the output, right? Because we expect only until Thane, but next thing suddenly I saw it was like, from where did it come?
No, no, I couldn't get you.
No. When we are doing a sorting, the expected output will be until Thane, like Goa, Mumbai, Pune, Satara, Thane. There should be a close bracket. But there
Correct,
was
correct,
something like a D type. I was like, from where this value got fetched? So I asked.
correct. Yeah, yeah, sure. Good observation. Yeah, we should observe these also small minute changes. This is actually telling you the similarly there is one more np dot unique is there. So some names are suppose repeated twice. So you can call them unique and it will give you unique names. np dot unique is also there. Not unique, not unique code. So in this case, actually city names are not repeated at all. So in case you forgot and write Goa twice
And it will
accidentally,
return Goa.
then it will remove that.
Remove Goa. Okay.
It will give you only the unique ones. Correct. Same you can do for integer. Same you can. Yeah, there is sorted. Yeah, this sorted is also already there, right, with us. This function. So in this also you can call. In this case, I think Unicode and nothing will come.
Ah, okay.
But because it is not unique, it is giving you currently two of them. But otherwise, it will also sort for you. So like NumPy has something. So I think yeah, after these indexing and I think these we talked about indexing many things. Let's one more topic is also there, I guess. Okay, MPy operations. Yeah, let me raise that. NP arithmetics we talked right. Multiply you can do directly to multiply.
Yeah.
Yeah, universal array. You can directly take the square root exponential anything. Max is there. So arithmetics we talked already. Yeah, so these are like yeah very general and I think then the exercises are there. Okay. Uh, Let me talk another some things. There is actually np.save where actually you can save some array. Saying suppose you want to save same array, but which format we are going to save that is yeah npy format is there, and here actually you can pass the array which you wanted to save. So when you did this, you run this command, you can see one file will created here. It is not visible to or readable to us, and probably the size will be very less also. We can check here. It is around 192 bytes, very small right now. But as the data will come into picture, you can save actually. So what is the idea is actually sometimes you did some operation on heavy of the data sets. Now you want to save them. You can save like this. And similarly, you can load them also. Loading is nothing but reading. And you can pass that name of the file. So there will be many other format also. Mm, After loading, it will
Why it is giving that? That array.npy was empty, right?
NumPy array. Sorry, NPY is I think NumPy only. Yeah. Python has, yeah, Numpy library. They say it generally is binary format and it's classic size reduction by 50%. So that's why the people use this many times or very less time, because it is not readable format, right? When you open them, actually you cannot understand anything. So people can avoid it, but you are sure like you are not going to open, or no one is going to open, but you can load it, but for later stage of your code. So then it is very useful. You don't have to store big chunks or big files of txt or csv, which is readable but yeah, no use, meaning you
When
don't want to use it. Yeah, so this is like better version. I think they are also talking about compressed versions are also there many. So np dot saves compressed. Let's see how it is changing, how much it is changing. Suppose we saved that same array but in compressed form, not npy, and we pass the file which we wanted to save. But okay, let's see. Able to save. Yeah, when we did this, uh,
it's becoming zip folder kind of.
yeah, it's actually more than that 246 byte, but it's fine. Yeah, it says we can store several npz format. The yeah, it's not much several. Okay. When you want to store more than one array, actually, so then actually you can pass
2D.
2D array kind of, or maybe you can pass like array dot two, and now it is also saved in the same file 460. But when you load them, actually, I think then sorry, load. Yeah, npz is the new format it comes, and oh, okay, how to see them? That is a new question. Let's see. Yeah, okay. New file is there, but it's in this format. Uh, oh, okay. Let's see for we can have something. Yeah, okay. So, okay, yeah, correct. I is there, right? Okay. So I think we need to write something like this, and so we need to print, right? Then data, and in the square bracket we can say array zero. Yeah. So I think yeah, this will give you this the first of the array, and data square bracket array one will give you the second one,
2D. Okay.
second array, 2D array one. In these way, yeah. So these are the things we wanted to talk array, and many more is like now it's like classic in what to say, algebra stuffs will come. It's like dot product also is there, np dot dot. So what it does, multiplies two arrays, but dot product is known as another type of product, which is similarly same actually when you do. Oh, sorry, no, it is little bit different because array was, wait a second, array was
Zero.
two-dimensional array, right? But yeah, this is dot product of same array in twice. But how it works is, I think, when you write again array, yeah. So this row is getting multiplied by this row. Sorry, 0, 4, and 8 and 16, one by one. So 0 will be multiplied by 0. Just check how dot works. 1 will be multiplied by 4, then sum it. 2 should be multiplied by 8, sum it. 3 should be multiplied by 12, sum it. And that number is 56.
Okay.
So yeah, this is Artham, meaning maths, algebra stuffs are actually coded here. Dot product, multiply and sum actually. You can see. Uh, these are some examples are also there how it will work. Can reshape and multiply them and all. So these are the things, and yeah, that is all. I think NumPy will have many things, but yeah, many more use cases are actually related to this. What to say? Linear algebra things, yeah. So I think NumPy dot add is also there. So, but in this case also you will able to add two of the array, and but it will give you the same result which we did. Array plus array will give. Yeah, and let's do a small exercise how you will plot them, because generally we will be later on using plotting. So there is one library, this matplotlib, very much used in this Python community by plot as PLT. And what we are going to do is, so yeah, let's define any function that is like z is equals to np.sqrt. Oh, okay, yeah, square plus y square. But yeah, we need x also. Let's say x and y. Oh yeah, we can do defining like this. Uh, Meaning variable assignment. One variable is x, another is y, and how we are defining them is okay, they are equally spaced and all. Oh, okay, we need many more things. So I think when we talked about this arrange, right? Np dot arrange. I give you this, right? Meaning start and end. You can also give the spacing also that we mixed. So suppose you put this. So spacing is like how much difference should be there in the edition. So in these cases, this is acting as a start and end. These are the step size. So after 10, it should be 10.1, 10.2, so onward, so forth, so forth. This is the thing. So let's this to be 20, and we have this values from minus 20 to 20 with the point 0.1 spacing, and we call this as a points to plot. Uh, and now what we will do, we will create a ms grid is also there, one more method. So ms grid, will do is it will create points, comma, points, and is going to store for us. So what it does is it created values based on this points. Uh, what why it is? Yeah, 1.1, right? So each values are nothing but minus 20 to 20 actually with the spacing of zero point 0.1, and similarly y will be same. Yeah, need to check how this MS grid is working. Returns the coordinates of the matrices vector. Okay. So these are actually giving you x and y coordinates. Yeah, that's why it is giving you this way. And z will do is what? It will try to do this operation over x and y for each of the values. So points were point of, yeah, I think we are, these are the some maths actually we the numpy are like meant for these to these operations, but for time being, yeah, let's just quickly I just finished this. Yeah, dot is there. I am show. Okay. And you can plot z and c map. Let's see how this is working. Dot dot cn dot dot color bar. So okay. Oh, nice. Yeah. Hmm. Oh, okay.
Where we will be using this thing like a map.
Yeah,
Like,
these are actually classic maths thing. I think this exercise which is given by this what to say? Actually, x square plus y square is a classic circle equations. So it is what it is creating multiple circle equation, but the density is decreasing from the center to outer areas. That is the idea, but yeah, we are not going to use this. But the idea was, suppose you wanted to plot z, right? So z is actually function of x and y. As the x are going away, we are x and y's are going outside, they are decreasing in nature. But actually, yeah, easier case will be, I can, yeah, later on we can, yeah, simplify this. I think easier case will be, say, suppose x is yeah, x is some numbers and y is actually nothing but x square. Then if you plot them, plot dot scatter, I think, yeah, scatter is there, and you can plot x comma y. It's like this is the picture it will come, right? X square is nothing but this way. So these are some basics plot you might be doing to the see the correlation between x and y. So currently x and y's are very you can say well defined. That's why it is coming this lines. Otherwise, if your x are suppose np dot suppose I think random. Oh, random dot and n is there. Yeah. This will generate some how many points suppose, yeah, thousands point, but yeah, we need to check. So yeah, even for that also, actually it will be some pattern will come into picture. But yeah, We can check x and y. Y is also not defined here. So suppose we did randomly did the plotting for y, 1,000 points, then it will be something scatter. So it is like finding some correlation between x and y. So x can be your height and y can be your weight, or student versus their yeah, class, or age versus salary. Actually, very classic example everyone gives in machine learning. Or for your yeah house prediction model is there, right? You want to check area versus house is the correct or not. So you will plot x in the one axis, y will be another axis, and try to check correlation. So positive correlation is there, negative correlation. So I think yeah, these we will cover later. But I was saying like yeah, we can plot also these values. So these are the some ways we can plot and visualize them. Yeah.
Rishik, one doubt. It is like to use this matplot, we should be already having our values in NumPy, like NP.
Or yeah, one way is plotting in NumPy, getting the values in NumPy. Another other ways is also there. You can pass these values as list also.
Okay.
It's not necessary, but NumPy is like faster. Yeah, that's why we are using right now.
Okay, most commonly used is like NumPy, and then it will have a range of datas. Then
Hmm.
you're trying to do something with math plotting, that is like a plotting work.
Correct, for plotting only.
Okay.
Okay, and before I come close this, we have one more. Uh, I think, and we talked about right. Similarly, we have or also, or we define this. Uh, this one. Sorry. Uh, okay, why? Shift.
Slash.
Okay, yeah, this one. It's above backward slash. Yeah. Wait, let me see. Is it the same? Yeah. This is also there. You can try. Maybe yeah, you can check on array. So it will say all are true because everything is greater than 5 or lesser than 10.
Okay.
Yeah, yeah, correct. Otherwise, you need to put other way around. Greater than 10, lesser than 5. Then you will see some false, right? And inverse condition is also there. You can pass tilde sign. It will change the. Oh, okay. It should not be on list. So it says it should be on these conditions. Yeah. It just change the condition. So these are the things. And I think equal to and so
Not equal.
equal to and not equal to you are aware, right? Yeah. So these are the only which is equal to 10 but not equal to 5, or so you can play around this condition and check how it is working. I think yeah, this is all I wanted to talk about NumPy. I think yeah, you can do exercises, read about them if you do not able to understand this any of the syntax. I will share yeah later the video also. Then you can play around with.
Yeah, for me, this at least will take time. I mean,
Yeah,
initial
yeah. You
whatever
have one
question
entire
we
week.
can.
Yeah, then you can continue your exercise. Okay, then.
Okay.
Okay. Yeah.
And do we have any side